Akademi YouTuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh and good evening. Hi everyone. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with e-Didik Malaysia and Kelab Guru Malaysia with the hashtag bermula percuma, selamanya percuma. Okay, before we proceed, let's begin our session with the recitation of Kitab Al-Fatihah for the Muslim and a moment of silence for the non-Muslim. Al-Fatihah. So how is everyone doing today? My prayer that everyone is in the good and best of health and ready to proceed with today's class. Before we start, let me introduce myself first. My name is Nun binti Muhammad Noor. You can call me Madam Nun. I am lecturer from College Matrikulasi Negeri Sembilan. Today's are very special for me because I am your moderator and also I am the presenter. Okay? So for the record, we are live on my channel now. So as a sign of support to me, can you please subscribe my channel? Okay. As usual, our class will last approximately 1 hour. The certificate link and the credit claim link will be given at the end of this session. Remember that you can only use e-DD email to claim the certificate. For the credit claim, you need to collect the 1 letter and 5-digit codes which will be announced separately during our class today. So be sure to follow the class up until the end to get the complete code for the credit claim. I would also like to remind all of you, if you wish to post comment in the chat box, please use appropriate language and use appropriate profile picture. I am pretty sure that all of you are a very good and excellent students. Okay, so stay focused, and if you have any question, please write on the chat box, and we will try. I will try to provide you the answer. And now, before we start, I will announce the code for the credit claim. So the first letter and 2-digit code is A33. A33. Okay. So let's start with our class today. All right, before I go to the topic that I supposed to discuss, I want to introduce you the physics team. This is the physics team led by Madam Rosmaya. And then this is a mathematics team led by teacher Im. Okay. And biology team led by Cikgu Faiza. The chemistry team led by Cikgu Shahnun. The Perakunan Ekonomi Prayu team led by Madam Fizi. And Academy YouTuber also have apps. Okay, you can download from the Google Play. So in these apps, it is a lot of video from a lot of teachers with the academic video, so you can get all the reference there. Okay, now we go to our purpose today, which is for today's class, we will do the revision and exercise for the past year question for the topic momentum and impulse. So actually this is the mid-semester test for the semester 1. Okay, so before I go to the question, okay, just go through what you have learned about the momentum and impulse. Okay, so first, you're supposed to know the definition of the momentum. So momentum is defined as the product between the mass and the velocity, and the direction of momentum is same as the direction of the velocity. And for the impulse, it is defined as the product of force and time, and it is a vector. Force impulse is a vector, so direction is same as the constant force on the object. And for the impulse momentum theorem, because of, if you look at the unit for momentum and impulse is same, so it's relate with the impulse momentum theorem, which is state that the impulse of a body equal to the change of the body's momentum. So given by the equation of J is equal to mv minus mu, which is mv minus mu is the change of momentum. And another way to get the impulse is from the F versus T graph. So referring to the F versus T graph, the area under the graph is represent the impulse. Okay. And the second part in this topic is about the conservation of linear momentum. So principle of conservation of linear momentum state that in an isolated or closed system, the total momentum of the system is constant or remain unchanged. Okay, and because of momentum is a vector quantity, so we need to consider the x component and y component. So for the principle of conservation of linear momentum, sum of linear momentum at the x component is constant, same with the sum of linear momentum at the y component also constant. And about the conservation of linear momentum, we always apply in the collision. So because of collision is an example of a closed system where there is no external force acting during the collision. So the forces that act during the collision is only action and reaction force. Okay, so total momentum is always conserved. So we can write down that the sum of linear momentum initial is equal to the sum of linear momentum, total linear momentum final. Okay, and for the principle of conservation of linear momentum, we will apply for the one dimension and two dimension collision. And here are the similarities and the differences between the elastic and inelastic collision, because of there are two types of collision, elastic and inelastic collision. So the main point that I want to highlight is for the similarities, both obey elastic collision and an inelastic collision obey the principle of conservation of linear momentum, which is the total linear momentum initial is equal to total linear momentum final. But for the kinetic energy, so for the kinetic energy in for the inelastic collision, the difference is the kinetic energy is not constant or not conserved. Okay, which is the total initial kinetic energy is not equal to the total final kinetic energy, and the rest is the differences between the elastic and inelastic collision. Normally for the calculation, we focus a lot on this part. Okay, now we go to take a look at the first question. I hope that you have tried to answer the question. I have give you the link so you can try to answer the question, and you can share your answer in the chat box. Okay. So for question number one, a rubber ball of mass 20 gram moving at the velocity of 30 meter per second hits a wall and bounce back with the same velocity. Calculate the impulse. Okay, very simple question, but it is a very important hidden information. So as usual, as I always remind you, to list the information given from the question. So referring to the question, given the m, okay, if you look at here u, in this part, if you consider that u is to the right, so initial velocity is positive 30, and when it's rebound, meaning that the final velocity is to the left, so v is negative. So this is very 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 important hidden information. And when you want to calculate, or if you can see the diagram, if we consider that the object moving to the right, so initial velocity is positive. So to calculate the impulse, we use the impulse momentum theorem, which is J is equal to delta P, so mv minus u. And in this case, if we look at here, v is, because it rebound with the same velocity, so v is negative 30. Okay, we substitute, okay, minus with u is 30. So in this case, if you consider this situation, impulse is negative 1.2 kilogram meter per second. But let's say, if, because we don't know your assumption, okay, let's say if you assume that the wall is at this side and the ball moved to the left. So from the sign convention, we accept that to the left is negative, to the right is positive. So in this case, u is considered negative. Okay, and when the rubber ball rebound, v is positive. So when you do the calculation, you will get the impulse positive value. Take a look here. Because of final velocity is positive and initial velocity is negative to the left, So you will get the impulse is positive. So it is depends on your assumption on the direction. Normally, for me, I advise you to follow the sign convention, which is to the left positive, to the right positive, to the left negative. Okay. So for question number 2, this is to show the application of the impulse, how to calculate the impulse. Instead of from the calculation, we also can calculate the impulse from the graph. So, referring to this question, a kilogram object is act upon a single force in the x direction in a manner described by the graph as shown. So, determine the change in momentum acquired by the object. So, the question said that change in momentum we want to calculate, and if you look at the given information, uh, even given the mass is 2 kilogram, but from the graph you will get two important information, which is at the y component we get that the F is equal to 14 Newton, but at the x component we get the T, delta T, which is delta T is initially 2 second, final is 8, so it is equal to 6 second. All right. And when you want to determine the change in momentum, so we know that the area under the graph is represent impulse, and from the impulse momentum theorem, we know that J is equal to delta P. So in this case, J is equal to change of momentum, which is represent the area under the graph. Because of that, for the calculation, we just calculate the area under the graph, which is this is the area of the triangle, right? So half times 14 times 6. So you will get the change of momentum, which is 42 kilogram meter per second. Okay, so this is very simple question actually. Okay, for question number 3, an object P moving with velocity 3 meter per second collide head on with another object Q of mass 6 kilogram moving with the velocity 5 meter per second in the opposite direction. Okay, if the collision is perfectly inelastic and the final velocity is 2.5 meter per second, you need to calculate the mass of the object P and also the kinetic energy of the system after the collision. So referring to the question, it is a lot of hidden information. Yeah. For example, first, because we want to calculate the mass of the object P, so I just put it question mark. And then MQ, so UP is 3 meter per second. Okay, do take note that this is head-on collision. So for the head-on collision, normally both object moving in the opposite direction. That's why UQ is negative 5 meter per second. Either one, but it is okay because of Q is moving in the opposite direction, so we consider UQ, initial velocity for Q is negative 5. And perfectly inelastic, remember the similarities and differences table just now. For the perfectly inelastic, after the collision both object will move together, so meaning that final or after the collision, total mass after the collision is MP plus MQ, because of they move together with the velocity of 2.5 meter per second. So how we want to calculate the mass of object P? So referring to the principle of conservation of linear momentum, I'm sure that this is familiar with you. This is only to understand, to recall back what you have learned in SPM. Yeah. So final is MP plus MQ because of for the perfectly inelastic, they move together. So you just need to substitute correctly. Do take note that the UQ is negative. This is the important hidden information, and because of that, you will get that the MP, the mass of the object P, is equal to 90 kilogram. Okay, and then to calculate the kinetic energy of the system after collision. So kinetic energy, do take note that this is a very also important part, because of impulse momentum is a vector quantity, but kinetic energy is scalar quantity. So to calculate the kinetic energy of the system after the collision, we just use the kinetic energy equation, which is half mv square, but our m is both object P and Q move together. So MP plus MQ, they move with the velocity V. Because of that, when you substitute all the value, you will get that the total kinetic energy after the collision is 300 joule. Okay, do take note that this is because of kinetic energy is scalar quantity, we just substitute the value. Okay, now we go to the question number 4. For question number 4, figure shows trolley A of mass 2.5 kilogram move at a constant velocity 3 meter per second collide with the trolley B of mass 3 kilogram which is at rest. So at the same time, yeah, I want you to refer to the information that I list here. mass of the object A. Okay, why I state that UA is equal to negative 3? As I said, referring to the sign convention, normally to the left is negative. So I consider that the initial velocity for object A is negative. Okay, and object B is at rest, so UB is equal to 0. After the collision, trolley A moved in the opposite direction at the constant velocity 2 meter per second, while trolley B moved at the constant velocity and hit a wall. The wall exerted an impulse of 18 Newton second on trolley B. So we need to calculate the velocity of the trolley B after the collision with the trolley A. That's the first situation. Second situation is when you need to identify the or determine calculate the velocity of trolley B after it hit the wall. So both is velocity of trolley B, but in two collision, different collision. Okay, the first part we want to calculate the velocity of trolley B after the collision with the trolley A. We apply the principle of conservation of momentum. Because of this is only one dimension, we can use directly this equation. And do take note that when you substitute for the UA is negative just now, UB is 0, and then VA is 2 meter per second because of the trolley A move with the continue move with the velocity of 2 meter per second, but B move at the constant velocity. Okay, so VB, we don't know, we want to calculate. Alright, because of that, if you calculate, you will get that the VB is negative 4.17 meter per second. Okay, why VB is negative? So when B collide with A, when A collide with B, so B will move to the left. That's why the answer is negative. Same answer, same sign with the A initial velocity for A, because they both move into the left. Okay, so second part, and do take note that because of it stated that you need to calculate the velocity, you need to mention the direction. So because of that, you can state that the direction for the trolley B is at, or the direction of the velocity of trolley B is to the left. Okay, for the velocity of trolley B after it hit the wall, so after it hit the wall, we can use the because of impulse, the wall exert an impulse, so we can use the impulse momentum theorem. Okay, referring to the impulse momentum theorem, do take note that uh, after the trolley B collide with the wall, it will move to the right. Okay, so UB still negative because of move before the hit the wall. The direction is to the left. So when you calculate, you will get that the B is equal to 1.83 meter per second. And same thing, you need to mention the direction, which is trolley B rebound to the right. That's why we get that the VB is positive. Okay. So the part that I want to highlight to all of you is uh, you need to be very particular with the direction of the velocity. Okay. And for question number 5, okay, figure shows a ball of 0.2 kilogram moving with a horizontal velocity of 20 meter per second and hit a wall. Okay, after 0.01 second, the ball rebound with its initial velocity along the same path. Okay, if you look at the information given, the mass of the ball and then initial velocity of the ball, because of this ball moving to the right, so the initial velocity is 20 meter per second, and then the t time of impact, time when the ball hit the wall, is 0.01 second, and because of it the rebound, as I said, the ball rebound to the left, so final velocity of v is equal to negative 20 meter per second. Now we want to calculate the impulse of the ball. So I know you can imagine the equation that we can use, which is referring to the impulse momentum theorem. So referring to the impulse momentum theorem, J is equal to delta P, and then please substitute correctly. Where if you list correctly the information given, you can substitute correctly. Where V is equal to negative 20. All right, and you will get that the impulse is negative 8 kilogram meter per second. Okay, and then for question number 2, what is the average force exerted by the ball on the wall? So referring to the impulse given, first you calculate the force exerted by the ball on the wall, which is referring to the definition of impulse, F times delta T. So you can get F, which is equal to negative 800 Newton. But the question state that you need to calculate the average force. Because of that, the average force is 800 Newton. You need to state the value for average force, because of from the calculation you get the negative, because of force is same direction with the impulse. For question number 3, state whether the collision is elastic or inelastic. Explain your answer. So to identify either it is elastic or inelastic, remember the differences of the elastic collision and inelastic collision. The difference is in the kinetic energy. So because of that, what you need to do is first you need to calculate the initial kinetic energy, because of we can identify the either elastic or inelastic, either the kinetic energy, total kinetic energy is equal or not before and after the collision. So initial kinetic energy, if you calculate, we use the half mu square, because of this is initial kinetic energy for the ball, you get 40 joule. And for the final kinetic energy, if you calculate, you will get same, which is 40 joule, meaning that this collision is elastic collision. So you need to explain your answer. So your answer is because of initial kinetic energy is equal to final kinetic energy, so the collision is elastic collision. Okay. So this is the way how we identify either the collision is elastic and inelastic. Okay. Now we go to the question number 6. So for question number 6, an object P of mass 8 kilogram moving at 4 meter per second collide with a second object Q of mass 6 kilogram moving at the 5 meter per second in the opposite direction. So it is very important when you read the question, list the information following the correct symbol and also the hidden information. So in this case, if you read the question, you will see that a mass of object P is 8 kilogram, moving 4 meter per second and collide with the second object Q, moving 5 meter per second in the opposite direction. So UP is 4 meter per second, but UQ is negative 5 meter per second. Okay, negative 5 meter per second. And then after the collision, object P move in the opposite direction at 1 meter per second. So we know the VP negative 1 meter per second. Okay. And referring to the information given, you need to determine the magnitude of the velocity of the object Q after the collision. Okay, first take a look at the solution. We want to calculate the VQ. We will apply the principle of conservation of linear momentum. Okay, good evening, Simon Lee. Okay, welcome to the tuition class. Okay, so referring to the principle of conservation of linear momentum, you just need to substitute. Okay, this principle is quite easy, but you need to substitute carefully. Okay, because of if you refer to the question, it's not stated the value is negative or positive, but you need to identify, you need to read the question carefully. Let's say it mentioned the opposite direction, so make sure that you know which one is negative and which one is positive. So when you list the information, easier for you to substitute the value. Okay. In this case, UQ is negative 5, VP is negative 1. Okay, and we want to calculate the VQ. So have you tried to answer this question? Maybe you can share the solution. Okay, VQ, you will get that 1.67. So in this case, we know that the VQ is moving to the right. Okay, because of the value is positive. Okay, so because of it is stated, but because of it stated magnitude of the velocity, so no need to mention the direction. Okay, and then okay, now you need to show that the collision is inelastic. Is it the collision is inelastic? So how you want to prove? Remember the difference between the elastic and inelastic collision? So we refer to that differences. So we need to calculate the total initial kinetic energy and final kinetic energy, because of inelastic collision can be identified if the initial kinetic energy is not equal to the final kinetic energy. Okay. So first you calculate the initial kinetic energy, but in this case, because of there are two object P and object Q, right? there are two objects, so you need to calculate total kinetic energy, initial kinetic energy, total, meaning that initial kinetic energy for object P and also object Q. In previous question just now, because of we just consider that ball, so we just calculate the initial kinetic energy of that ball. Okay, but in this case, because there are two objects involved, object P and object Q, so you need to calculate the total initial kinetic energy for both objects. So it is equal to initial kinetic energy is 139 joule. And how about the final kinetic energy? Total final kinetic energy, because we have calculated the V here. Another thing that I want to highlight is, please remember why we not substitute UQ, for example, -5. Actually, because of kinetic energy is scalar quantity. No need to consider the direction. Even your value for V is negative, doesn't matter. Okay, you can substitute the positive value. Okay, same thing with the VP. Okay, VP is 1. So when you calculate for the total final kinetic energy, you will get it is equal to 12.4 joule. So because of, if we compare between the total initial kinetic energy and final kinetic energy, the value is not equal. So to explain this answer, you need to mention that because of total initial kinetic energy is not equal to the total final kinetic energy, so the collision is inelastic collision. Okay. So I hope that I give you two example. This is not I give you, because of this is the mid semester test question. So very good. For the different years, they give different types of question. Okay, so you will learn a lot. And okay, we go to the question number 7. But I think that before we go to we discuss because of start question number 7, 8, 9, and 10. This is about the two-dimension collision. So before we continue, I want to announce we take a break for a while, because we have run almost 29, almost 30 minutes. So I want to before I announce the third digit code, we take a break for a while. Okay, so take a look at the
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, so welcome back everyone. Please listen carefully. I want to announce the third digit code. So the third digit code is number 9. Okay, the third digit code is number 9. Okay, so I hope that you can write down somewhere so you can claim the credit after this. Okay, now we will continue with question number 7. Okay, are you ready? Okay, so for question number 7, wait. Okay, question number 7. A homemade rocket is moving at a speed of 45 meter per second. The rocket breaks into two pieces of equal mass which fly off with velocity v1 and v2. Okay, as shown in the figure above. Calculate the magnitude of V1 and V2 and neglect the effect of gravity. Okay, referring to the question given, okay, I just because of we need to list the information following the symbol. So initially the homemade rocket moving with the initial velocity of 45, and then I just consider initial mass is equal to 2m because of after the rocket will break into two pieces of equal mass. So I consider that mass final, which is for the M1 and M2, when the two pieces of the when the rocket is break into two pieces, so M1 and equal to M2, which is equal to M. Okay, so understand this part, yeah? Because of final, after it's break into two, the mass m for each each piece. So initial mass is 2m. Okay, this is another way to this is hidden information too. Okay, and then we want to calculate the both final velocity for both pieces. Okay, so referring to the take a look at the diagram. I just put the line there to show that initial before the collision and final, which is after the collision. We consider the collision, and referring to the final situation. In this case, a V1 and V2 is not at the X or Y component. Am I right? Because of that, what we need to do, if because the velocity is a vector quantity, we need to resolve into X and Y component. So here I resolve V1X and V1Y for the V1 and also V2. Okay, to resolve to the X component, which is represented by V2X, and Y component represented by V2Y. Okay, so to calculate the magnitude of V1 and V2, we will apply the principle of conservation of linear momentum, but for the two dimension. So in this case, firstly, okay, we need to take a look one by one. So initially, this is the total linear momentum initial at the X component, meaning that we need to see the X component and also at the Y component separately. So at the X component, initially, MU, so M initial U is equal to final is M1 V1X plus M2 V2X. Okay, why plus here? Plus is because of, if you look the resolving vector V here, V1X and V2X is to the right, both to the right. So it is a positive direction. And the rest is you need to substitute M initial, as I said, to M initial velocity for the rocket is 45, and then for the one V1X is V1 cos 60, referring to the resolving vector. V2X is V2 cos 30, and if you look at that, the M at each part of the equation there is a M, so we can cancel the M. And finally, if you calculate, you will get that the first equation. So our first equation is in terms of V1 and V2 because we want to calculate the V1 and V2, right? Okay, so from the X component, we get first equation. And now take a look at the Y component. For the Y component, so if you look at the initial situation, there is the rocket is not moving at the Y axis, right? So total linear momentum at the Y axis is 0, but at the final total linear momentum at the final or after the collision, we have the V1Y and V2Y. So if you look at here, the sign here is negative. Why negative? So you need to refer to the resolving vector here. V1y is upward, V2y is downward. So that's why V2y we need to minus because of V2y is downward. And you substitute, make sure that you resolve correctly. V1y is V1 sin 60, V2y is V2 sin 30. And if you calculate, you will get the second equation. Why? Because of we still have no value for V1 and V2. So this is the second equation. Now, if we have two equation, we can solve it, right? Okay, what step that you can do, because of this is V1 equal to 0.57 V2, we can substitute equation 2 into equation 1 to get the V2 first. Am I right? So in this case, when you substitute in the equation 2 into equation 1, you will get that the V2 is 77.92 meter per second. This is the magnitude of V2. And to calculate the V1, just substitute the value for V2 inside the equation 1. So you will get that the V1 is equal to 44.42 meter per second. So this is the application of principle of conservation of momentum for the two-dimension collision. Okay, we just need to calculate the magnitude of the V1 and V2. All right. And for question number 8 is also for two-dimension collision, but it is quite different. Two object P of mass 7 kilograms. So take a look at the information here. And Q mass 5 kilogram, move with the velocity 6 meter per second and 8 meter per second on the smooth surface as shown in the figure. So the object collide and combine at C. The combined object travel with the velocity v. Okay, so referring to the information given, because of object P and object Q is in the different component. Am I right? So U positive to the right. For a P is to the right, Q is upward. So both UP and UQ positive value. This is also hidden information, but luckily because of given the positive value, the positive situation, positive direction of motion, so you can use directly UP and UQ as positive value. Okay, what happened? We want to determine the velocity V. Velocity after the collision, because of after the collision both of them combine, so we don't know the direction of the velocity. What you can do, we can do the assumption. Okay, our assumption is after both of them collide and combine, they move into this direction. You can assume to any direction, but of course not at the x or y component, right? Because both of them are from the y and x component. So if we assume that the value of V make an angle theta from the x component like this, so we know that for the final velocity, you need to resolve to the Vx and Vy. And now we want to determine the V. To determine the V, you need to know the value for Vx and Vy. So for this purpose, we refer to the principle of conservation of linear momentum, which is total linear momentum initial is equal to total linear momentum final, or before collision and after collision. So this is the situation before collision. This is the situation after collision. Okay, and then first take a look at the x component. So MPUP is equal to MP plus MQ because of after the collision. Okay, for the x component, we only have the object P because of Q is at the y component. You Q at the x component is equal to 0. Okay, so I just not write down here. And after the collision, they move together. So at the x component for Vx is equal to V cos theta. So this is also resolving vector. And for the y component, because of vector object P is at the x component, so no value for object P, only object Q for the initial momentum. And after the collision, Vy is to upward, so V sine theta. Okay, represent the Vy. Okay, referring to the equation 1 and 2, please open. Please open. Okay, sorry. Referring to the equation 1 and 2, so we want to calculate the velocity V. And how you want to solve it? So we can divide equation 2 to equation 1 because of sine per cos is equal to tangent. Okay, sine per cos equal to tangent. And when we divide 2 into 1, if you look at here, firstly, we can calculate the theta lah. Because of V here, 2 divided by 1, V will cancel. MP plus MQ also cancel. Okay, V also cancel. So first we can calculate the theta. So because of that, tangent theta is equal to, we just substitute MQ, UQ 5 and 8, and PUP is 7 and 6. So because of that, you get the theta is equal to 43.6 degree. And from that theta, you can substitute in one of the equation. Then you will get the V. Okay, so the V is equal to 4.83 meter per second. Meaning that after the collision, both P and Q move with the velocity of 4.83 meter per second. And do take note, you need to calculate the velocity, so you need to mention the direction. So don't forget, you need to mention the direction. Direction is 43.6 degree above the positive x-axis, referring to our diagram, because we get the we do the resolving vector referring to the diagram. Because of it stated that you need to determine the velocity, of course, don't forget to mention the direction. And for question number 2, show that the collision is inelastic. So remember the difference between the elastic and inelastic collision. So it is in terms of kinetic energy. The inelastic collision, the total kinetic energy is not conserved or not equal. So is it correct? Then you need to prove it. You need to show. So to show, you need to do the calculation. So first calculate the total kinetic initial kinetic energy for the P. And in this case, we can sum both object P and Q. Excuse me. Why? Because of kinetic energy is a scalar quantity. Okay, doesn't care the component. And then you will get at the initial value for the kinetic energy is 286 joule, and for the total final kinetic energy, so it is equal to 140 joule. Okay, because of both initial and final kinetic energy is not equal, so the collision is inelastic. So you can show that the collision is inelastic referring to the calculation of the initial and final kinetic energy. All right. Okay, now we go to the question number 9. Okay, for question number 9, in a pool game, a cube. Okay, for question number 9, initial object not at the x or y component. Okay, so this is the difference. So in a pool game, a cube ball moving with the velocity of 0.8 meter per second and at the angle of 45 to the x-axis, okay, as shown. The cube ball collide with a stationary red ball as shown in the figure. Both balls have the same mass. After collision, the cube ball moves with the velocity of 0.5 meter per second at the angle of 25 to the x-axis, and the red ball moves with an angle of theta to the x-axis. Okay, if you read the question, referring to the question, I just use the subscript C referring to the cue ball. R is the red ball. So initial velocity for C and R is given, and R is stationary. So the initial velocity is 0. MC, uh same, is stated just now, right? Same mass, have same mass. So MC is equal to MR. I just represent by M because of the mass is equal. And VC, after the collision, VC move with the 0.5 meter per second. Okay, the cube ball. And we want to calculate the velocity for the red ball. Okay, how you want to solve this? All right, now take a look at the final situation after the collision. Okay, because of you need to sketch the motion of the ball after the collision. So to sketch the motion of the ball after the collision, okay, this is cue ball stated here. Yeah, cue ball move with the 0.5 meter per second at the angle of 25 from the x component, x-axis, and red ball theta from the x-axis. Okay, so this is the situation that we can sketch for the motion of these two ball after the collision. All right. So referring to this sketching, find the magnitude and direction of the velocity of the red ball after the collision. Because we know the cue ball, the final velocity for the cue ball. So for the red ball, final velocity, of course, because of the VR velocity of the red ball is not the x or y component, we need to resolve it to the x and y component. And then for the cue ball also, because we will apply the principle of conservation of linear momentum at the x and y component to calculate the magnitude and direction of the velocity of the red ball. Okay, to apply the total principle of conservation of linear momentum at the x component, because of it, total linear momentum initial meaning that before collision. So cue ball is not located at the x or y component, so you also need to resolve the cue ball to the x and y component as shown in the diagram. Okay, because of that, we know that MCUCX. Okay, because of this is at the x axis, x component, so we just take the UC at the x component and VCX and also VRX. And now we need to substitute the value. As I said, MC, the mass of the cue ball and the red ball is equal. So we just represent by M, and you substitute the UCX. UCX here is 0.8 cos 45 VCX because we have the value for VC. So it is equal to 0.5 cos 25 and both is positive direction. And VR cos theta is also in the positive x direction. So we can cancel the m because of m located at each term in the equation. And when you solve it, you will get the first equation. Why you get the first equation? Because we have no value for the velocity for the red bond and also the theta. All right. And then, of course, we need to find the second equation from the y component. So, referring to the y component, and why this is negative MC UCY? Because of UCY is downward. UCY is downward, so negative MC UCY. Okay, red ball is still 0. And then MC VCY minus MRVRY. Why minus? Because of VCY is upward, VRY is downward. And then you substitute, we do the same thing, substitute the value, don't forget the negative sign, and you can cancel the mass because of each term in the equation, the mass is located there. And referring to that relationship, referring to the equation, you will get the second equation. Same thing because we still know value for VR and theta. And if you have equation 1 and 2, what you can do to calculate maybe we can calculate the direction first, which is theta, because of sine per cos is equal to tangent, right? So for the solution, we divide 2 to 1, so we get the tangent theta is equal to 0. Tangent theta is shown, and if you calculate theta, you get theta is equal to 81.8 degree. Okay. And for the VR, when you get the theta, you can substitute the theta in the first equation. So when you substitute, we get that the VR is equal to 0.79 meter per second. Now you can state that the direction of VR, which is 0.79 meter per second, is 81.8 degree below the positive x-axis, referring to the sketching diagram, referring to the diagram that you sketch. VR is located below the positive x-axis. Okay. And for question B, find them. Oh yes, this is B. This is because of we have calculate magnitude and direction. Okay, that's question number 9. And this is just to show why theta is below the positive x-axis, as referring to the sketching. Yeah, our initial sketching. Okay, now we can go to the last question. Okay, for question number 10. Okay, for question number 10, a stationary 5.5 gram carom striker disc. Okay, you familiar with the carom game? Okay, I like it very much. So if you understand the principle of conservation of linear momentum, you can win the game actually. Okay, so a stationary 5.5 gram carom striker disc is flicked by the player and move with a speed of 0.5 meter per second. It then collide with a 5-gram carom main target. Okay. Figure shows the direction of both these after the collision. All right. Okay. So it is show clearly sticker disc, striker disc, and also the target disc, which is represented by disc number 2. Okay, object 2. And we want to find the magnitude of the average first. We want to find the magnitude of the average force exerted on the carom striker disc if it is in contact with the player finger for 0.08 second. Okay, first question, you want to calculate the average force, which is it is involved only between the player and also the striker disc. Okay, because of that, I just sketch. This is the situation. You need to understand the situation, okay? Because of the first collision is involved the player and also only the disc, the striker disc. Okay, so because it's stationary striker disc, so initial velocity is equal to 0. After the player flick the striker disc, the striker disc move with the velocity of 0.5 meter per second. Okay, this is the first situation. And it stated that just now what this it is in contact the player finger with the disc is only 0.08 second. So to calculate the average force F, we refer to the principal impulse momentum theorem. Okay, impulse momentum theorem. So impulse is equal to F delta T momentum is mv, the change of momentum is mv minus u. So when you substitute, you will get that. Okay, make sure that because of v is in the SI unit, so m you're supposed to change to the SI unit. That's very safe lah. Okay, and then you will get, and also the because of s in time is in second, so you get that the average force is 0.034 newton. Okay, so this is the value for average force exerted on the carom striker disc. If the contact with the player finger 0.08 second. And now we need to calculate or determine the final speed of both discs after the collision. Okay, this is the second situation. The first situation between the player with the striker disc. Okay, for the second question, to determine the final, meaning that we want to calculate the V1 and V2, the velocity for the first disc and second disc. Okay, take a look at the solution. Okay, in this case, if you look at the, to calculate the final speed for both these, yes, I just change back. Okay, in this case, I want to use M1 and M2 in the gram unit, but you need to see why. Okay, before that, I just pick up the final collision. At the final collision, after ball striker this strike the target, the carom target, so they move into this direction, V1 and V2. So because of V1 and V2 is not at the X or Y component, so we need to resolve. Okay, V1 represented by V1X and V1Y for the X and Y component. So V2, V2X and V2Y. And it is very important for you to resolve on the diagram because you can see the direction either to the right, upward, downward. So you can see clearly, easy for you to apply inside the equation. Actually, when you do a lot of exercise that relate to the principle of conservation of linear momentum, there's no problem for you to solve the question that relate to the principle of conservation of linear momentum. Okay, here now as usual, because of we need to apply the x and y components, so we will look at the x component first. Total linear momentum initial at the x component is equal to total linear momentum final at the x component. So in this case, before the collision, because of object 2 current of course, even not stated the speed or the velocity for the carom or target carom, but we know that the carom is not moving, right? The disc is not moving. So for the carom target, the initial velocity is 0. Okay, u2 is equal to 0. Okay, in this case, we do the same thing. You need to substitute the m1, the mass. I just substitute with the unit g. Okay, why? Because of actually at each term in the equation, we can we will cancel the g. We can cancel, so not wasting our time to use the value. And then for the V1x, it is equal to V1 cos 35 given the angle, and V2 cos 65 referring to the angle given. And what we do, cancel the G first. Okay, so the calculation is quite shorter. And then because we have no value for V1 and V2, we get the first equation. You will see the sequence. You can see the same every time we solve it, the step is same. So if you understand, there's no problem. Okay, that's only the first equation. So for the second equation, you will get from the y component. So at the y component, if you look at initially, both moving at the x component, so no no momentum at the y component. So initial linear momentum is equal to 0. But for the final, if you look at here, m1v1y minus m2v2y, y minus, because of v2y is downward. And then you just need to substitute. In this case, we still substitute the m1 with the unit gram because of we will transfer and this part to the right, okay, to another side. So if you solve this one, you can cancel the g first. Okay, and then you will get the relationship between the V2 because we bring the negative to this side, so it become positive. So you get that the V2 is equal to 0.70 V1. So the second equation we get from the Y component. The first equation from the X component. Okay, and then what we need to do to determine the V1, first we can substitute equation 2 into equation 1. So when we substitute, because of our V2 is 0.70 V1, okay, our V2 we just substitute here and solve this equation. And you will get that the V1 is equal to 0.46 meter per second, because this is the speed, so no need to mention the direction. How about V2? So if you know the V1 here, of course lah, you can substitute V1 into equation 2 to get V2. And if you calculate, you will get that the V2 is equal to 0.32 meter per second. Okay. So this is the final speed for both these after the collision. All right, I have shared with you for the two dimension, especially because of it is very important. There are four cases starting from question number 7, 8, 9, and 10, and four different situation of the collision. So I hope that, but the main point is you know how to resolve the vector v correctly, velocity. You need to resolve correctly, and you can substitute the value correctly by considering the positive and negative direction for the x and y component. So if you have no problem with that, I'm sure that you can solve all the two-dimension collision correctly. Okay, so I think that's it for our class today. So don't forget to leave your comment in my video so that I can improve my next presentation, and also don't forget to subscribe. Okay, so that's it for today's class. Okay. Oh, because of I am alone, huh? See, I forget now. So, Alhamdulillah, we have reached the end of today's lesson. Congratulations to those who are able to follow our lesson from the beginning till the end. Thank you so much and congratulations. So, before we end our session for today, I will announce the last two-digit code for the credit claim. Okay, please write down somewhere. So, the last two-digit code is 56. 5 and 6, 56. Okay, the last two-digit code. So total is 5. Okay. So all of you, please stop posting your comment for a while. And don't forget to click the subscribe button and make sure to activate the icon bell so that you will not miss the next class lesson. Then, if you find that this lesson is beneficial, please like and share to your friends on your social media. Spread and share the goodness. Okay, once complete, type down on the chat box before the certificate link given as the token of appreciation. Thank you for your dedication in joining the free online class today. So, okay, now I will put the, okay, you are welcome, Chinteng. How Chinteng? Okay, so this is the link for the, you can get the certificate link, you can, wait, okay, sorry. Okay, it is a quite problem. Okay, wait, certificate link and okay, copy. So I will put in the comment. That's the ECJ. First, I put the ECJ. Okay, link for CJ and link for the credit claim. Okay. So, please take note that the link will end half an hour after this live, make sure that to use the EDD email and MOE email to log in. So if you use incorrect email, it will not be entertained. If you haven't got one, please apply. The link apply the EDD email already given in the chat box. So if you wish to get more information on the online classes, you can go to the academyyoutuber.com, and those who haven't joined EDD Junior Telegram, please do so. So once again, I would like to thank all of you for joining today's class. You are very awesome. Thank you for your support. Feel free to share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from all teachers throughout Malaysia for all the students throughout the country. Thank you for being a YouTuber Academy supporter too. I think that's all for now. See you in another session. So please remember the hashtag bermula percuma, selamanya percuma. So, Assalamualaikum warahmatullahi wabarakatuh. Stay safe. We will meet again next week. Same day and same time. Okay, bye.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTube.